Thanks. Your whininess is starting our video for today. That just started recording. So Michelle, apparently he did not ask you. All right. So we'll get to the start slide. That's yet to come.
So homework's 12:09.
If we get there. If we get there. So if there is homework, if there's new homework, it will be 12:09. If there's new homework. So we ended here last time on 12:08 talking about our complex numbers, and we had not gotten to the point of multiplying them because we wanted to take a step to the side and make sure that we understood all of that stuff. If you missed class yesterday, Thomas people or people that were on the tour, who can tell them what we did and like if it helped you or whatever? I think you have.
We watched a bunch of videos on imaginary numbers.
So they're on the playlist on Schoology, not just like some random videos. They're the Welch Labs one.
They're pretty good.
They were pretty good?
Yeah.
Okay. Caleb?
They were about like the history of the imaginary number, and then it started talking about like how you can sort of use them.
Is the
It didn't necessarily talk about it, like referenced it.
Is it imaginary?
No, it's they said it was a real, but you said you wanted to call it lateral number.
Yeah, so it really is like these values are lateral to our number line. Thank you so much. So if you think about like positives being this way and negatives being this way, and they're like on the floor, then our imaginary numbers pick up off. And there's a really cool point in the last video, the 5th one that we watched, where it showed the rotation. So if you weren't here yesterday, please go watch the first 5 in that playlist. It'll take you like 20 minutes because they're all like 5 or 6 minutes or less. A couple are 2 or 3 minutes. So the big thing about I that makes our principal function work is that I squared is -1. So we want to jot that somewhere to remind ourselves that we are going to be using that principle a lot here. So when we do this distribution, the 3i distributes in, and even though it's not a variable, it behaves like one. So when we multiply with it, it comes along for the ride. If we multiply I by an I, it's going to give us I squared. Brian?
Why couldn't you like use it as a variable? It's basically
It is representing a value.
Is
So,
that a variable?
No, variables are representing an unknown. We know I, and it can't ever change.
It's like an assault.
So, when we're talking about solve for x, we will eventually know x, but we don't know it to start. And it could be a range of things. It could be one thing. It could, like, we know I, and it's never going to change. So that's why we can't use it as a variable. It's not a variable. So, we distribute that through. My I squared, I then substitute with -1. And then I rewrite, putting my real value first, just because we like it better that way. It's not really right versus wrong, but complex numbers are better if we write the real and then the imaginary or lateral value. Any questions on part A, where it's done out for you? Try part B, where we're going to need to apply our FOIL method. I have the YMCA stuff on my head.
Me too. Why?
Because she just asked me to put it on, and I did. She didn't really ask me why. I mean, it's a classic.
Yeah. Like, who doesn't listen to the YMCA to start math class?
Only the weird people.
Anyone would tell me those values you get when you FOIL? You don't have to tell me. You don't have to tell me the final. Just the first thing you get when you FOIL. Carmen?
-4 minus 8i minus 3i and minus 6i squared.
Boom. Now combine like terms and sub out. So Michelle, this becomes.
Well, couldn't you say just +6?
Yeah, so we could really just go ahead and say that this is going to be +6. But once we think about it being +6, we might as well combine it with the constant that we have. So I have the -4 and the +6, which combines to 2 minus 11. C, who can recognize what's unique about, or like, not necessarily unique, but what is special about C? Ethan?
It's like A plus B times A minus C.
What do we call that? Forget? Difference of squares, because my first value is going to get squared, but then the difference of this being negative and this being positive makes my outer and my inners cancel each other out, so I really just have first and last. So I square my first and square my last, and I end up with, well, negative 6 squared, and I times negative I. So that's the interesting thing. We get I times negative I, which becomes negative I squared. My smart board is all jacked up.
What the?
It's all, there's a section in there that it's all goofed up. I'll try to reorient again in a second. So my negative 6 squared becomes 36.
And then time wouldn't just be times, well, I guess that times 1.
So I squared would become negative 1, but the opposite of negative 1
Well,
would
it
be...
wouldn't be times. There would be a sign in between that. It's not 6.
Yeah, this is not multiplication.
Oh.
So if we bring that in as a negative, this needed to be addition up here.
Wait.
Okay.
For the negative 6 squared, wouldn't you need to put parentheses around negative 6? Or would you?
Yeah, well,
Okay.
so if you're putting it in your calculator, yes. But if we're talking and we know it's negative 6 squared,
Just making
yeah.
sure.
So when we say it, I should properly say quantity negative 6 squared.
I just want to make sure I'm getting
Wait.
it right.
Yeah, you're good. Because it's negative 6 times negative 6. So if we had written it over there, or if this isn't all jacked up, there's like a no man's land here. So let me reorient. Do the got it really quick. Just give me a second to reorient, then we'll talk. Lord. Somebody was doing stuff on the roof, and it bounced my smart board around, or my projector around, and now the orientation points are on a bad pixel, or on a bad receiver on the board. See if this works now. Well, I'm just checking if it jumps the line or anything. If it orients on a bad point, it gets all of you. Alright, what was that?
Okay, I was confused about where you got odds. Because, okay, so, like, the eyes would cancel out.
Let's
So you
walk
had-
through this a little
so
slower.
You had 36, right?
So I get negative 6 times negative 6, so we know that's negative 6 squared. Then my outers are negative 6 times negative I, so I get 6i. Then 6 times, or I times negative 6, so minus 6i. 6i minus 6i is going to cancel out. Then I times negative I. So if I don't have another operation, I would just have plus I times negative I. I times
confused
negative-
about how you got that, though. 'Cause wouldn't it be minus negative I squared?
Where would that minus have come from?
The negative I.
You can't use it for negative and minus. So, hold on. Because you might be getting confused because the I squared will bring in a new negative. So this minus right here, what was playing as minus in the binomial, really belongs to the I. So when I do the multiplication for the last, it's I times negative I. And when I look at just setting up each value, I have addition between each different term. But then if I add a negative, I can make it subtraction. So the middle part cancels. That becomes 36. My I times negative I becomes negative I squared. I squared is actually negative 1. So the opposite of a negative makes this 36 plus 1.
Wait, I said that. You
Okay,
said
yeah, I
I was
got
wrong.
that. But
No, if I did, I'm sorry. The board jumping got me all screwed up with what I was writing.
Oh wait, no, I said 30. Okay, now I get what I said. I just said it wrong, but I was assuming 1, but then I didn't realize it was plus 36, not times 36. Was
Yeah. There was
Okay.
you, and I didn't capture it because I couldn't.
37.
But there was an operation up here that I hadn't written.
Okay,
That was my bad for not writing it there. But yeah, there's always assumed addition between terms. Yeah. Nice. So let me get this to capture this time. Maybe I'll email Mr. Sherg this video and ask him pretty please for new smartboard. Or to like switch out one of the the one in the family room has a projector mounted on it. I need to use that projector so my TV can still be used. So Michelle, what'd you get when you did 7i times 3i? So alright, so walk me through it. So you get
Oh,
Oh,
lordy.
nice.
You get 21i squared, and then I squared.
looks like a child is doing. Sorry, go ahead. So
I squared is -1.
So this is really 21 times -1.
Oh, Lord.
I'm just going with this.
Try again.
Do you want to use the chalkboard?
You know, we might just have to. No, I'll use the left side of the board. It's only the right side of the board that's all screwed up.
Well, you just have to replace the right half.
Yeah, that's good. Just cut it in half.
Yeah.
Send it back to Smart. Excuse me, can I have a new right half?
Excuse me.
So then this becomes 21 times -1 because remember, these are really multiplied with each other. Like if we want to talk about an operation, and it becomes -21. And
Man, that was a lot easier than I thought it was. I just had some complex crap. That was
Complex.
Mhm.
Oh, hilarious.
And if thinking about that as multiplication is at all confusing, remember we're talking about 7 units in the imaginary axis or in the imaginary plane. So if I talk about 7 units in the real value, that's 7 times 1. So this is really just 7 times the value of a radical -1.
I's.
Alright, division applies by the same rules that we are used to with our algebraic operations. So i's divided by i's will cancel out. Power rule still applies, so if you have a higher power on top and versus bottom, we can just do the subtraction. So any questions on problem 5, the one that is done out for you here? Check out what, so look through the process. When we multiply by -3i over -3i, we're really multiplying by 1.
That was very crazy.
Thanks. I'm glad that I have your support at least.
Okay.
So this value, I'm going to stop writing. This value, we're doing nothing, right? We're multiplying by 1, which doesn't change anything. But that rewrites our values to actually become -9i squared, and it throws some more i's up in here. The point of that is so your denominator can get rid of the I values. So once I get an I squared down there, becomes -1, and makes my denominator 9. Then I can split this, because just like our division rules, if we had a binomial on top and a monomial on bottom, we can do 36 divided by 9 gives me the 4. -27i divided by 9, again, treat it like it's a variable, even though it's not. -29 divided, or -27 divided by 9, -3. And the I comes along for the ride. We get one complex number in the end.
Wait, why wouldn't you just multiply it by 1 or by I?
You mean like I over I? Because the 3, so, what's the easiest way to describe this? Looking at the fact that if I just did I over I,
Cancel.
Yeah, wouldn't that get the very? Wouldn't that get
because
the same thing?
you'd still end up with, let's play with it. I can't write to the left there, but I forget exactly why. It's been a year since I taught this, so let's play with this. So if we didn't do this, and instead did I over I, this would become 9i plus 12i squared over 3i squared.
Oh, because it
Gives you a-
squared and I turns -1.
Yeah, but so still, if we keep processing through this, we get 9i minus 12 then.
That's
Just did it.
Oh, God.
man, look at that.
Mr.
I'm
Hudson,
just
I think
gonna
your
just
smart
leave
book's
it
having
and
a
just move
stroke.
on.
If it doesn't work, you could just cry.
And
It's okay to cry outside.
-3.
We should go outside.
See, it would work. Oh, it's cold and gross.
Okay, so there are other situations where, so yeah, I agree. In this one, it does work out the same. But there are other situations where we need to use the complex conjugate, which is a really fancy way of saying the opposite of what we have. Because when we get it to cancel out, we want it to cancel out to a positive. So the main reason we use complex conjugates are for when we have a binomial on the bottom. So if we look here in part B, the complex conjugate of our denominator there is just the opposite of the value that we see. So the opposite of the 1, -1, opposite of the -4i, +4i. If we didn't know to multiply by the complex conjugate, and you just try that I over I process again, we're going to get a really messy value. But by doing the complex conjugate, watch what happens. Ignore all that. Well, I'm going to work from up here down because I can't work this way. So go ahead and set up 2 plus 3i over 1 minus 4i, your original, on numerator and denominator. We're going to multiply by, and you can write it however you want. You could do negative quantity of, or you could go ahead and flip them both. So this will be -1 plus 4i, -1 plus 4i. What does that make happen? I know. I know.
I was thinking about something else, but that's funny.
What does that make happen in your denominator? We'll deal with the numerator in a second.
Would it just cancel?
So, binomial times binomial, we gotta FOIL it out, right? Let's think through this. First, -1.
Oh, God. Oh, Lord.
Oh my.
Let's try to find somewhere.
Give your smart book some medicine. It's not doing too well.
staple.
It drew a staple.
Wait, why is it like
Excuse this interruption. Could I have
I
Josh
have a
calling to the
hypothesis.
office? Josh?
And what is it?
That when the dude walking on, they were working on the HVAC, and that bounced, and it moved. And I think my orientation points are now on a couple dead pixels, like from just long-term use. This is the oldest smartboard in the building. So it's orienting and not lining up to make the grid. And if it can't line up to make the grid, say a corner falls off into infinity or something, then the whole grid is skewed a direction. So it's pulling all the ink that direction. Let's try this again.
you got a little black hole?
The denominator becomes -1
There we go.
for my firsts. My outer would be positive 4i. My inner would also be positive 4i.
Oh.
So I get plus 8i. And, sorry, that gives me the negative 16i squared. Let's go ahead and deal with our numerator while we're over here.
Wait, that is 16.
Yes.
What's the line below it? Is
Oh,
that
that's
the
a
line below
1.
it? Oh.
Hey, you really could have made some.
You guys are going to come in tomorrow. It's just going to be a chalkboard here. I don't have time to do that tonight.
What are you drinking?
Iced coffee.
Fancy. When you get home, should you tell your wife that you love her, assuming that you do?
She has conferences tonight, and I'm going up to McGraw-Hill for a feedback panel.
Like,
But yeah, when I do get home, sure.
Like the next time you see her.
Or text her.
But don't lie to her. Like, make sure you actually love her and then tell her.
All right, I can't. Can't.
Holy Lord.
We're gonna give me a copy of your notes.
Yeah, you should just write it on the actual computer and then.
Well, yeah, but I can't write on the computer because I don't have the smart slate hooked up right now.
That looks really nice. Let me tell you that.
This looks like.
I'm going to use the document camera. I just need a copy of 12.8, and I gave you guys all.
You're
of
doing
them.
modern art.
Yeah, you can use mine.
I think it's
Yeah,
a
use
sign that
Brian.
we should
He's
just
a leader.
skip this chapter. Yeah.
No.
Ryan's
Obviously
basically,
not.
Ryan's basically
Just
not
give up.
filled out his, so
You
it's
can use
it's
mine.
basically a blank one.
Yeah, the smart card's against it.
Oh, that's it. It's just
started.
it's the waves coming off of the wave
It's
here.
scared of you. When did this start happening?
It's really bad today comparatively, but it's been glitchy. All right.
Like you came back from winter.
It's been happening since he started to grow that beard.
Yeah.
That's what they were just
I
hypothesizing.
thought it was since the
Thanks for jumping on board,
the
Michelle.
smartboard with the marker.
I'm glad you're gonna hate like all the other haters.
No, it's a beautiful
I'm not gonna
beard.
hate.
I like
So
it.
you're just hating
You
because
are
you
like
can't
a
grow
Taylor
it.
Swift.
Beautiful.
Grow the goatee. I would just
It's
say.
amazing. I like it.
I
I'm
like it.
against
It makes him look like an actual adult, not some teenager who's
It
walking
makes
in
him
her
look
teenage class.
scary.
When you-
That's
No,
the
you
best
can't.
thing.
He looks like a teenager.
Like young,
Like
like
mustache.
Then it's hard to respect.
Do you not respect teenagers?
No.
Okay, I hope you have a whole
Have you
other
seen how much
problem.
respect he
They're
gives to all of
moving.
his classes?
I don't know. It's pretty okay to me.
Which out. You interact with him very much?
I'm trying to make sure. So again, complex conjugate. Keep your real value. Flip the sign of your quote-unquote imaginary, but really lateral. Because remember, we just use the real axis.
So we messed up.
Yeah. So now that I can actually write, let's fix this.
That's where it looks like a weed.
So for B, we start with
So wait,
two.
it wouldn't be a binomial times a binomial. It'd just
It's
be a-
yeah, it still would be. So here,
Oh, what?
grab a post-it if you just need to cover up what you did. Again, my apologies. I've not taught this in a while. I just that part slipped my mind. 1 plus 4i. So it should create. This is why I thought it was fishy. It should create a difference of squares. Is essentially all we're doing. So your first term, your real value should be the same. Your
Oh, okay.
imaginary value should be the opposite. So on bottom, in my denominator, that will cancel out your b term.
So you just flip the imaginary number value?
Yeah. So you are going on the opposite side of the real axis. So if you think about the videos, the Welch Lab videos that we were watching, and he pulled that imaginary axis up off the table, or up off his paper, that's this axis. It's not really the y-axis. I wish they would. Well, so y is how far up the imaginary axis they are, how many units. So there are y units up the imaginary axis. We just go the opposite across we reflect it essentially.
And then the x-axis would be the number line.
Yep, x-axis is your real value. So, my denominator, the point of this is so that I get 1 squared, which in this case will just be 1. The b terms cancel each other out, and then we get negative 16i squared, which will be very nice. We'll deal with the numerator here in a second, because that will become 1. I squared becomes negative 1. Which
Like the one, first number.
this is a 1, this is a 1. The only I is right here. We use lowercase I. We always use lowercase
I
I.
always forget that.
Lynn?
Oh, hello.
Hi.
So, did you just take the denominator and like double it?
So we foiled out, but the outer and the inners cancel because what we create with the complex conjugate is a difference of squares.
I get the foil. I'm just wondering how you got the red. Like, where is that coming from?
This is 1, so we're multiplying by 1, decided by my denominator. When we look at the denominator, we say, okay, keep the real value, what it is, so that it'll just square itself, but make the imaginary value the opposite of what it is. So if you want to visualize this, so you need to go watch those videos that you missed yesterday. That's why this isn't totally making sense. But when we have our real number line and then our imaginary number line, this is not a y-axis. This is a new plane that is the values that we call imaginary. They're not. They're real. They actually exist. We can work with them. They are solutions. So, however far we were imaginary, either positive or negative, we go and reflect that across the real axis. That's how we get our complex conjugate. So it creates, the point of it is so that the denominator, let's get this up as well, so that the denominator will then actually become 1 plus 16, and it makes it nice and easy. It's just a whole value. Now we got to go back into our numerator, but that's how we got the values that we multiplied with. Other questions? All right, do your numerator. Guys, is that you making noises, or is that a 7th grader I need to go take care of?
That was me being annoying, sorry.
Sorry, it's just hard to focus when making noises. So, our first term, our outer and our inner, I'm going to go ahead and do that work over here so I can combine them already. Yeah, it's very blurry. And not working on the smart board is making me not able to erase.
Yeah, that's not really. I guess that's a little bit.
Yeah, but the bottom makes it easier.
Yeah, the bottom makes it easier.
It takes 20 minutes to get there.
It's just a
So we now have removed any imaginary values from the denominator, which is our goal.
Okay, so wait, is this like an answer?
And we, like, sometimes that'll be reducible, and we would be able to do both divisions. The other way, like the last simplification that we could do is just write it as a real part and an imaginary part. So we could write this as negative 10/17 plus 11/17 I.
Do we have to do that, or can we just keep it in like C?
Make sure this is on your notes, just so you're familiar with that, like, last step. But it's really arguable which one. It depends on your application. So if you're trying to figure out where the value is, like how to plot it, you're going to want to go ahead and do that. Because then this is how far I go on the real number axis, and then this is how far I go on my imaginary axis. Good? Wait, move on. Try C,
Wait,
or got it, or whatever it's called.
What do you mean?
Okay, what were you saying, Carmen?
Oh,
Do you have a question, or no?
Well, yeah. Oh, there it is.
How did you simplify the top value thing?
Where at? Like back here?
Here.
So 12 times I squared, we know I squared
Yeah,
is -1, so that becomes -12. 2 minus 12 makes my -10.
Oh, okay. That's okay.
Yeah, Michelle?
17.
For the got it? Where?
oh, shit, I can work on this. Oh, shit, alright.
Alright, did you go back and make sure that this is a plus? because we had
How do I
written it wrong the
simplify
first time.
This.
Like that, we have a positive 1 and a positive 4i for this binomial. Because that's why we get 3i and 8i, and then a positive 12i squared to start. Then my I squared becomes -1.
Wait, so negative I squared is just positive 1, right?
Yeah, the opposite of I squared.
Wait, we're supposed to do the God right now, right?
Yes.
Okay, sorry.
You're fine. You're good. You're good.
How many more parts to this chapter?
We may cut the chapter in the middle. I'm debating on us just doing another formative assessment tomorrow to see where we are, and then just kind of really make. I mean, it only goes to 12-12, but we may really do another one of those quizzes and make that like chapter 12 mastery part 1, and just do two different masteries.
So wait, Mr. Upson, would you say this is like the hardest unit?
Yes. Yes, definitively.
What's the next one?
We get the probability and statistics.
Yes.
And
I want-
combinatorics and factorials and fun things like that.
I like
need,
that.
I need, because I don't.
That's
I-
like-
I
This is why they
forget a
save
lot.
that until after your.
So this is
Until
like
after
this
you
is like
survive.
the third quarter.
We're in the home
Work,
stretch.
yeah, it's like the home stretch, and then after that, it's just easy.
Which is evil, right? Because the third quarter sucks no matter what.
Third quarter's the worst.
Um,
Make this like.
But there's a lot of stuff you have to learn beforehand, and you need this before state testing. All right, what is my complex conjugate here, Brian?
Oh, it would be 3 minus 4i.
Can you explain?
Yeah,
So-
you flip the 4i. Because it's the imaginary value.
So did you watch those videos? Were you here, Suri?
Yeah, but I did plus. Nothing.
Okay, do you understand why it is what it is, though? Okay, because instead of, like, if you imagine that first parabola from his first video where he pulls the plane up and then you realize, oh, the solutions are above that plane, if you went to the opposite side, like below the table, the negative side of that plane. Okay, then, let me pull some more of this over here. We do that math. Might as well use a different color. So, do your denominator first because you know it's supposed to do a difference of squares. So, Brian, what'd you get there?
9 plus 16.
9 plus, well, okay, yeah, 9 minus 16i squared. But if you process all the way through, you can see that you're going to get 9 plus 16, which we know is going to eventually give us 25, which is a nice denominator, reducible, perfect square, all that stuff. My numerator,
Oh, I'm such an idiot.
I'm still
I just
doing
realized
it.
I left it there and just went on, and I could have just solved it. That was my bad.
okay, you're forgiven.
Okay. 25.
So your first is going to give you 15. Outer gives you negative 20i. Inner gives us negative 6i. And last, which I'm running out of space, gives us 8i squared.
Do you just foil the top and bottom?
Yeah, you foil both. So we have binomial on top and binomial on bottom. So if it's binomial times binomial, we got to foil. Yep. And remember, we're really just distributing, but foil is the process we use to make it easy. Make sure we don't forget anything. Combine your i's, so we get 15 minus 26i, then minus 8, because that I squared flips the sign of the 8. 15 minus 8, combine your like terms. So then if I wanted to rewrite this as real and imaginary, 7/25 is 0.28. Because remember, we could actually just make our denominator 100 and then convert to decimals. And 26/25 would be 1.04. Yeah.
And then you correct that in like fraction, or if you're like graphing.
I mean, I think that's just as easy to graph because if you know where a fourth is, you're just slightly over a fourth. But if you're talking about like trying to plug into a graphing utility, sure, rational numbers are just as easy to work with. So you could have really thought that through from here.
That's what I just wrote.
Yeah.
Wait, what is it?
If we convert to decimal, just because we haven't done that yet, this one's nice and easy to convert to decimal because my 25 can become a 100. I know the questions on using the complex conjugate.
I like.
So it takes, again, for the reason of why we're doing it, it takes this crazy value, which we would have a very hard time plotting, and makes it completely manageable. I can now plot this using a real number line and an imaginary. Another plane, but not your standard Cartesian plane. We just make our, I don't even know what we call that plane. I gotta check on that.
Is that gonna be like the next unit?
What, like graphing them? Well, we already did a little bit of that up here.
Yeah.
So we would just come out, I mean, we would want to change our scale because our values, like 0.28 is going to be real hard to show here. But yeah, we'd go 0.28 on the real axis, over to the right, and then down 1.04 on the y-axis.
Can you use Desmos to get that, or would you have to change?
I don't know if Desmos does imaginary.
Is
You
it
can check.
imaginary number calculated? Or like graphic?
I don't know. They're constantly adapting and changing, so check it out. Let me know. When we, this gets really fun. When we want to factor using complex conjugate. So look through this for a second. I'll shut up just so you can glance at it and try to wrap your brain around it.
That just seems so unnecessary.
Yeah, why?
So it's the think box. God, I can't write on the board. Well, I probably can a little bit.
Let's find out.
If this,
Oh!
if that was negative,
That's a brother.
if we had x squared minus 16, that would be difference of squares, and we could have x plus 4x minus 4, right?
Oh, but since it's a positive.
But since it's a positive, this is not factorable using real numbers. So if we don't have a graphing utility, and and even actually if we plug this in our graphing utility, it might tell me that there's no solutions, because this parabola is going to be shifted up 32 units. So our solutions are on the imaginary plane, so we then break this up and say, since this isn't factorable using real values, let's break it and factor it using our complex conjugate. So we can set up that difference of squares, but instead of just having x plus 4 and x minus 4, it's x plus 4i and x minus 4i. Because when you FOIL out your original binomial and the complex conjugate, it creates your x squared plus 16 and cancels out that b term.
Alright.
So not factorable using real values, completely easily actually factorable using imaginary. Right?
Would you do it like you would complete it, like you would do it like completing the square? Would you do something
No, it's
similar?
easier than that.
Oh, sweet. Okay.
Like, are you saying, could I change this to do completing the square?
Yeah.
There is no b term here. Because remember, in completing the square, there has to be a b term. So this does not come from a perfect square binomial, like trinomial. This is not a perfect square trinomial. So yeah, that's why we can't. Yeah, then I can FOIL the binomials and rewrite and get back to where I was and prove that yes, this does work if I want to check it and make sure. So my solutions here then are going to be negative 4i and positive 4i.
Or those would be like the
Those are your solutions, yeah. At negative 4i and positive 4i, that's where your parabola would cross because it is solvable.
So then you'd use like an imaginary. So wouldn't that mean the imaginary axis would have to be? Or am I
So it's
you
just
don't know.
like
Imaginary.
when...
Oh no! So I was just saying, we just flip over onto the.
No, you'd be solving for the number. Not the end of it.
So I know usually we say the imaginary thing is the vertical line, not the horizontal.
So these values, where it crosses then, would be at 4 up on the imaginary and -4. So, like, that's your parabola crosses on this axis.
That animation looks really hard to do because they probably, it's not like they like, oh, they just like made it. They probably made it very like
You'd have to model
specific.
it
Yeah.
and then.
No, this, like, because when they pull it up.
Question. How, I mean, I know you said we could graph imaginary stuff by having the y-axis be imaginary.
So I'm never going to ask you to graph like this,
Oh,
like the
'cause I was gonna say-
parabola's solutions.
Yeah, I was gonna say, like, would that mean that it would, like, it's not, like, we can't really graph it on, like, a two-dimensional...
Oh, you can graph the parabola, just when you graph it, it looks like it doesn't have any solutions.
Okay.
But we know it has to.
On a different plane.
Yeah, in
Alright.
that different plane. So the solutions just don't exist in the real plane.
Alright.
They exist in our lateral plane, which gets called imaginary because we all suck and we kept it. Right.
Would it be a different shape than that? Like, could it be?
It would still be parabolic, but it would look... I mean, this is not 2 times and 32 shifted up.
No, like, could it look like a different shape? Like, instead of, like, always looking like that, could it look different?
Yes. I mean, if you made it really wide... I gotta get you guys out of here, too, because I can't make it that late for Spanish. But I don't know exactly what you mean by look different. Like, what do you...
Like, be a different shape.
Would a parabola always form that shape on the 3 axes?
No, I mean, if it actually had real value solutions, then, like, imagine that this actually was down below this, then it would create, like, this really... Like, I think it would be almost, like, reflected through itself. Because imagine that this didn't happen till below the imaginary axis, and the whole thing, like, morphs. I don't know. It's a really good
So
question.
it almost, like, pulls it off. Kind of, like,
So, would
Yeah.
that then be, instead of being down that way, would it be up that way?
Yeah, I think. But I don't even know if we would need to do that. Because we wouldn't need the imaginary.
Like, some reason to do it. I mean,
Well, not that we would need to. I'm not saying that we couldn't, but if there's a reason, if there's a need, because our solutions would be real.
Mr. Hudson, I've got a question.
Yeah.
Since we work a lot with, like, we use Blender a lot,
Yeah.
that looks something sort of like how if you take, like, if you duplicate all, like, the, like, right.
55 años.
So if you made, like, a U shape out of lines, right?
Yeah.
Duplicated that and
did not get
pulled
tall
it up,
Okay.
Yeah. Well,
couldn't you make that shape? Yeah. That's what I'm saying. So I'm saying it'd be really cool if you had, like, 3D modelers. And that's how you can teach people the imaginary crap.
but the question is how. I'm about to break this. How would it have this? How would you tell it to have this behavior?
like this specific measurement?
Yeah, like this is following a specific rule based on the parabola. It is behaving how it is based on the function x squared plus 1.
You'd have
Because
to,
as we plug in like now our x's are those complex numbers,
Well, you're
or
not-
just imaginary numbers.
you could first, like, model the actual, like, graph, and then
Yeah.
model that on top of the graph.
I would just say it'd be
Yeah.
cool if you could, like, as an example of how to teach kids about imaginary numbers, since they're kind of funky, you could model, like I say, Brian, you could model a graph and then show them in real time. You pulling the graph off the axis.
So we need y to equal 0, right? We need the function equal 0. That's on this line, right? So if we have one solution, imaginary, it's like right there. Okay, it was shifted correctly. Yeah. And if we have 2, then it meets at 2 different points as it passes through to make that y equal 0. So it's just really interesting. I mean, if you want to play with it in Blender, go for it. I just don't know how you would.
maybe
tell
that
it
should be
to
our
do
challenge
that.
for Mr. Russ, to see if we can actually
Well,
make
you could
something
also just had a point there,
And man,
and
what-
then you could fill in from there.
what if you guys were able to make this in Blender, but make the bottom your XY Cartesian plane, and make a third plane coming off of it that would be like your Z-axis, but we're really going to call it the imaginary axis. And then what if we could print this?
because you know how
Because
we
then
do,
I
like,
could use it.
we
in
can
the
do a
future.
top-down view, and depending on how we do it, if we do a top-down view, model this thing first, then pull it up, then we can go back into will be like a 3-dimensional view and edit it so it actually
So-
looks like this.
Yeah, I mean, if you guys can, that'd be sweet. It kind of just looks like a weird tongue.
So yeah, then is that curved down or is that just flat?
So this is coming up like this.
So that
So
would
it's
have
almost
to
like
be
it's like a
have,
tube,
an
but like
inward
you
curve.
cut off part of the
That
tube.
part would be down lower than that.
Yes, maybe. We'd have to get together
I
and
wanna
look at
see-
your stuff as you
Maybe
go.
it's gonna be
But get to Spanish. You're already way too late.
We don't
Um,
like Spanish.
But yeah, this would be
Maybe
sweet.
that should be our challenge, Mr. Estes.
Yeah.
You want us to make?
Just tell
He
us
also wanted
to
us to make, like,
that we can skip his class.
Yeah.
No, I cannot
No,
tell him that
digital
you
art,
can
digital
skip.
art.
Digital art. Yeah.
Well,
'Cause
I'll
he
talk
also-
to him
Mr.
about
Estes
you
also-
guys potentially doing this, but
He also said for us we wanted to make like an intro for like feeding stuff.
yeah.